Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P2413 indicates an EGR, exhaust gas recirculation system malfunction in the 2015 to 2020 Honda Fit. The EGR system plays a crucial role in reducing nitrogen oxide emissions by recirculating a portion of the engine's exhaust back into the intake manifold. Its proper operation is essential for optimal vehicle performance and emissions control. This malfunction might trigger illumination of the check engine light, leading to reduced fuel economy and increased emissions. Identifying and addressing the underlying concerns promptly can not only restore performance, but also prevent more significant engine issues in the future. The next slides will guide you through troubleshooting the P2413 code systematically. The error code P2413 signifies a malfunction in the EGR system specifically related to its functionality as monitored by the Powertrain Control Module, PCM. The EGR valve is crucial as it regulates the flow of exhaust gases back into the intake manifold to lower combustion temperatures and pollutants. It's typically located near the intake manifold or exhaust side of the engine, making it an integral component in the emission control system. The EGR valve position sensor measures the valve's opening and sends this data to the PCM, which adjusts the engine parameters accordingly. A faulty connection between the EGR valve and the PCM can cause the P2413 error to be triggered and should be checked during the troubleshooting process. Potential causes for the P2413 DTC can vary, but commonly include a faulty EGR valve itself, which may be stuck or malfunctioning. Open or short circuits in the wiring harness leading to or from the EGR valve can also create communication problems with the PCM. Sometimes, a simple bad connection due to corrosion or loose terminals at the EGR valve or PCM can lead to erroneous readings activating the DTC. It's essential to rule out these issues methodically before concluding on the replacement of major components. Reviewing the detailed diagnostics and checking connections is crucial in identifying the root cause effectively. Symptoms associated with the P2413 DTC typically include the illumination of the check engine light, which alerts the driver to an issue within the engine system. Additionally, the vehicle may experience rough idling and decreased engine performance, as the EGR system is pivotal for maintaining optimal combustion efficiency. Drivers might also notice an increase in emissions, which can lead to failing an emissions test if not addressed. It is vital to recognize these symptoms early on, as they suggest potential significant issues within the EGR system that require immediate attention to prevent further engine damage or diminished driving safety. For the first troubleshooting step for DTC P2413, turn the vehicle's ignition to the on position without starting the engine. This provides power to the system to run diagnostics. Use the HDS Honda Diagnostic System to clear any recorded DTCs, as this allows for a fresh start in diagnosing the problem. Once cleared, crank the engine and hold the throttle to maintain a constant speed of 3,000 RPM without a load. This step continues until the radiator fan activates, at which point the engine can be allowed to idle. Following this sequence assures that the PCM can run a diagnostic test for the EGR system effectively. Lastly, the EGR test needs to be chosen from the inspection menu using the HDS to gauge the system's current functionality. In the second troubleshooting step for DTC P2413, turn the vehicle's ignition to the off lock position. After this, switch it back to the on mode to prepare for the next diagnostic check. Using the HDS, examine key parameters, particularly focusing on the EGR valve position sensor. often referred to as EGR VLS. If the sensor signal aligns closely with the predetermined threshold of about 0 volts, it indicates that the system is functioning correctly. Conversely, if the parameters do not reach this threshold, further investigation is warranted, as it may indicate issues with the sensor or associated wiring. Step 3 involves turning the vehicle's ignition to the off mode to ensure safety while working on the electrical system. The next action is to disconnect the EGR valve 5P connector, which is pivotal for isolating the fault. After disconnection, turn the vehicle to the on position while getting ready to measure voltage. Use a multimeter to check the voltage between specific test points, number 2 of the EGR valve 5P connector and body ground. A reading of approximately 5.0 V indicates a proper supply voltage to the EGR valve. If this condition is met, it confirms that there are no issues with the VCC2 line, and the troubleshooting path can proceed to the next step. If the voltage doesn't match this requirement, further checks on the wiring and connections are necessary. The fourth step requires the vehicle to be turned to the off lock mode. Jumping the SCS service check signal using the HDS puts the system in a diagnostic mode, allowing for proper continuity testing. Next, you must disconnect the PCM connector C, 51P, isolating the PCM from the circuitry. Once disconnected, check for continuity between the test points within the wiring, the EGR valve connector number 2 and PCM connector C, number 30. A successful continuity check indicates that the wiring is intact. If continuity is present, it confirms that the VCC2 wire is operating correctly. Thus, further actions should involve checking the software version in the PCM or substituting it if necessary. In the fifth step, begin again by turning the vehicle to the off lock position. Following that, jump the SCS line using HDS, as this configuration allows further connectivity checks in the wiring. Then, you must disconnect the PCM C 51P connector. After this disconnection, continuity must be checked between the PCM connector C number 40 and body ground. A continuity reading confirming connection would indicate that there is a short in the EGRL wire between the PCM and the EGR valve. If there is no continuity, the EGRL wire is ruled out as shorted, and you can move to the next step for further diagnostics. Step 6 involves checking for continuity once again, ensuring that the vehicle is in the off-lock state. With the EGR valve 5P connector and PCM connector C both disconnected, continuity must be checked between EGR valve connector number 4 and PCM connector C number 40. A continuity check confirming connection indicates that the EGRL wire is unaffected by open circuits. However, if no continuity is found, this signifies that there is an open wire in the EGRL circuit that must be repaired to restore proper current flow back to the EGR valve and malfunction resolution. For the seventh troubleshooting step, begin again by ensuring the vehicle is in the off-lock state. Disconnect the EGR valve 5P connector to isolate it from the system. This step requires measuring the resistance between designated test points at the EGR valve side. The resistance measurement needs to be conducted between pin number 3 and pin number 4 on the EGR valve connector while it remains disconnected. A resistance of 100 kiloohm or greater indicates that the internal circuitry of the EGR valve position sensor is functional. If the resistance measurement is less than the threshold, this means the EGR valve must be replaced, as it is likely faulty and causing the P2413 DTC. In the eighth step of troubleshooting DTC P2413, first, Ensure the vehicle is in the off, lock state before disconnecting the EGR valve 5P connector. Measure the resistance between test points number 2 and number 4 at the EGR valve side, ensuring attention to details as the valve remains disconnected. A reading of 100 kiloohms or more suggests that there is no internal defect in the EGR valve's position sensor circuitry. If the measurement falls below this level, then a replacement of the EGR valve is essential to rectify the issue causing the P2413 code, ensuring ongoing engine efficiency and compliance with emission standards. At this part of the troubleshooting process for DTC P2413, jumper the SCS line while the vehicle is turned off, lock. After securing this step, the PCM connector C needs to be disconnected to complete the setup. Check for continuity between test points, PCM connector C number 4 and body ground. Successful continuity in this step would indicate a short within the EEGR wire linking the PCM and the EGR valve. If there is no continuity, the EEGR wire remains unaffected and the diagnostics will proceed to the next examination. For the 10th step in diagnosing DTC P2413, check the continuity once again while ensuring the vehicle is in the off, lock mode. With both the EGR valve and PCMC connectors detached, continuity should be established between EGR valve 5P connector number 5 and PCM connector C number 4. If continuity is detected, it indicates that the EEGR wire is functional. However, if continuity is absent, an open wire in the EEGR circuit must be located and corrected to achieve a proper signal flow between the components, thus fixing the issue behind the DTC. As we move into the 11th troubleshooting step, continue to verify continuity while the vehicle remains in the off-lock position. With the setup positioned as required, continuity must be checked between the EGR valve 5P connector number 1 and body ground. A successful continuity test signifying that the PG3 wire is in good condition allows for further movement in the diagnosis process. Conversely, if there's no continuity, this opens up the possibility of a break needing to be fixed between the EGR valve and the G101 ground, ensuring all electrical connections run smoothly. The 12th step focuses on verifying the EGR valve's functionality. Begin by reconnecting the PCM connector in its proper place. Subsequently, establish a jumper wire connection between terminals A and B at the EGR valve side, effectively powering the valve directly from a 12-volt battery positive terminal. After this, start the engine and let it idle. At this moment, connect terminals A and B with a jumper wire to the negative terminal of the 12-volt battery. If the engine stalls or runs roughly, it indicates that the EGR valve is functioning correctly, and other steps may be necessary to address the P2413 code proactively. Upon reaching the last step in troubleshooting DTC P2413, begin by turning the vehicle to the off-lock position. Remove the EGR valve carefully from its installed location and proceed to clean the intake manifold EGR port and the internal passage inside the EGR valve with a throttle plate cleaner. Effective cleaning is vital to remove any carbon deposits that could hinder the valve's operation. Once cleaned, reinstall the EGR valve and reconnect all previously detached connectors to restore circuit integrity. Finally, turn the vehicle back to on mode, reset the PCM using the HDS, and perform the necessary idle learn procedure to ensure the system adapts. Conclude by executing the EGR test function to verify whether the fault condition has been resolved. After completing the repairs for DTC P2413, an essential final step is verifying the repair. Begin this process by rechecking for any remaining or new DTCs using the HDS to confirm that the previous P2413 code has not returned. It is crucial to ensure that all prior issues are fully resolved and that the EGR system is functioning correctly. This verification guarantees that your troubleshooting and repair efforts have effectively addressed the malfunction, preventing further complications. Ensuring that the vehicle runs smoothly and meets emission standards remains the ultimate goal of this comprehensive troubleshooting procedure. Preventive maintenance for the EGR system can save significant time and money by preventing issues like DTC P2413 from arising in the first place. It's advisable to schedule regular cleaning of the EGR valve and associated passages to prevent carbon buildup, which can hinder valve function. Additionally, performing checks on the electrical connections related to the EGR system periodically is essential to catch any loose or corroded connections early, ensuring sensors communicate effectively with the PCM. Regular system diagnostics during routine maintenance can also help ensure optimal performance and emissions compliance. In conclusion, understanding the EGR system's significance is vital for any technician working with the Honda Fit. Following the structured troubleshooting steps for DTC P2413 systematically ensures that all possible failure points are addressed effectively, promoting optimal vehicle performance. Regular preventive maintenance helps to minimize potential EGR issues and preserves the overall health of the engine. Taking these proactive measures helps maintain compliance with emissions regulations, while also enhancing vehicle reliability and driver satisfaction. A well-maintained EGR system reflects efficient vehicle operation and contributes positively to the environment. Please like and subscribe to the channel. See you next time.